So in this case, we're interested in a situation where we have a mean of 65, that's mu equals 65, and a standard deviation, or sigma, equal to 5. So we're going to calculate the z-score. So in the first situation, we want a z-score for a value of 70. So z in general is equal to x minus mu over sigma. So in this case, our x value, or our observation, the value we want to find the z-score for, is 70. We subtract our mean of 65, and we divide by 5. So in this case, that gives you 5 over 5, or 1. So your z-score in this case is 1. That z-score represents that this observation of 70 is 1 standard deviation above the mean. And that should make sense, because if you take the mean of 65 and you add 1 standard deviation of 5, then you get that value of 70. So it's 1 standard deviation above the mean. In the second case, we're looking at an x value of 65. So notice in this case, it's the same formula, but now our x value is equal to the mean. So we just get 65 minus 65 over 5, which is 0. So in this case, our z value is 0, meaning that there is no distance between this value and the mean. It is actually equal to the mean. So the mean will always have a z-score of 0. And then in the last one of these, the x value is 62. So we want to find the z value here. So we take 62, our x value, minus our mean of 65, divide that by 5. That gives us negative 3 over 5, or negative 0.6. So notice in this case we get a negative z-value. A negative z-value means our observation is below the mean. A positive z-value means our observation is above the mean. So in this case, we can say that our score of 62 is 0.6 standard deviations below the mean. And that's how you always interpret a z-score.